Okay, fine. Listen. Function of a complex variable. Write the heading complex variable. Already given the definition, is it not? If z equal to x plus iy is a complex function, is a complex variable, then w equal to f of z is a complex function. W equal to f of z is a complex function. And w also can be written as u plus iv, that is equal to f of z. That means f of x plus iy. Is that equal to x plus iy? That means function of x plus, function of x comma y plus I of function of x comma y. This can be written as u plus iv can be written as f of x comma y plus I into some function of x comma y. See, for example, w equal to z square is, write down, for example, w equal to z square is, where z equal to x plus iy. Substituting z equal to x plus iy here, we will get that w equal to x plus iy whole square. Is it not? W equal to z square. Substituting z equal to x plus iy here, we will get that w equal to x plus iy whole square. So x plus iy whole square can be written as x square plus 2yxy plus iy whole square. So this can be written as x square minus y square plus 2y xy. Is it not? But this can be written as u plus iv. Come on, u plus iv. Okay, so here x plus x square minus y square, you can see it is a real part. 2xy is there, na? It is a imaginary part. Equating that a real part and imaginary part on both sides, equating real part and imaginary part on both sides, we get u equal to x square minus y square, v equal to 2xy. So w equal to what? Therefore w equal to what? U plus iv. U is a function of x comma y plus I v of x comma y. This is known as a complex function. Z is the, you should know what is the difference between that complex variable and complex function. Z is the complex variable, W is the complex function. Z is a complex variable, W is the complex function. One more example. In case I want to find that second example, example number 2, in case if W equal to sin Z, W equal to sin Z, then how can you express this as U and V? How can you express this as U and V? So Z equal to what? Write down where Z equal to x plus iy. Substituting Z equal to x plus iy here, we will get that W equal to sin of x plus iy. But sin a plus b is what? Sin a cos b plus cos a sin b. Then sin x cos iy plus cos x sin iy. Is it not? Now you should know that one result here, cos of iy equal to cos hy. Cos of iy equal to cos hy. Sin of iy equal to I sin hy. I sin hy. Cos of iy equal to cos hy. Sin of iy equal to I sin hy. Now substituting that value here, we will get that sin x into cos hy plus I cos x sin hy. So it is W na? But W equal to what? U plus IV. What is U here? Where U equal to sin x cos hy, V equal to cos x sin hy. When you are writing U and V, don't include that I. Okay, no need to write that I here. In case if you are writing V equal to I sin I cos x sin hy, mean it is wrong. Okay, because it is in the format of U plus IV. You are equating only the real part and the imaginary part. Okay, na? In case W equal to Z cube, W equal to Z cube, then what is the complex function? What is U and V? W equal to Z cube, then what is U and V? Do that. W equal to Z cube, substituting Z equal to x plus iy, then x plus iy whole cube, then expand this, x cube plus iy cube 3 x square iy plus 3x iy whole square. Then what do you get? X cube, real part. What are the real part here? Minus 3 xy square, then imaginary part plus I into 3 x square y minus y cube. So what is u here? The real part u x cube minus 3xy square. Imaginary part v equal to 3x square y minus y cube. So this is a procedure to expand one function as a complex variable to complex function. Write the note. Note 1. Single valued, write first, single valued and multiple valued function. Single valued and multiple valued function. When it is said to be single valued, when it is said to be multiple valued. When it is said to be single valued, when it is said to be multiple valued function. Then two sets are there. Z is domain, W is range or go domain. W is domain, sorry, Z is domain, W is codomain. If every value of Z, there is a single value in W. There is a single value in W, then it is a single valued. For example, write down W equal to Z square and W equal to 1 by Z are the single valued. W equal to Z square and W equal to 1 by Z are the single valued function. That means Z and W is there. Z equal to 1, then W equal to 1. Z equal to 2 for the first one, W equal to 4. Z equal to minus 2, W equal to 4. Z equal to 3, W equal to 9. Okay, this is one example. Here also we can see that W equal to 1 by Z. Okay, ZW. In case Z equal to 1, W equal to 1. Z equal to 2, W equal to 1 by 2. Z equal to 3, W equal to 1 by 3. It is also the single valued function. It is a single valued function. Multiple valued function. Multiple valued function is that if there is, write the heading, multiple valued function. if there is more than one value of z, more than one value of w corresponding to a given value of z, then w is called multiple valued function. So what is the definition here? Multiple valued function, if there is more than, here one word is missing, more than one value of w corresponding to given value of z, then w is called the multiple valued function. For example, w equal to z power of, okay, then we can write this as z equal to w square. In case w square equal to z equal to 1, if I give, then w equal to plus or minus 2. In case if I get that z equal to 2 here or 4 here, 4 equal to w square, then w equal to plus or minus 2. So you can see that w and then z and w. So in case z equal to 1, w equal to minus 1 and plus 1, z equal to 4, minus 2 and plus 2, w equal to 9, minus 3 and plus 3. Okay, so this type of function is known as that multiple valued function. Note 2, the distance between 2 points, z and z suffix 0 is mod z minus z0. It is a notation. The distance between 2 points z and z0 is z minus z0. Since z is what? Function of x comma y. z0 also the function of x comma y. If you find the distance between 2 points, distance is d equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. So it is that modulus of the function. Is it not? So this is can be written as mod z minus z0. Note 3. The circle, it is one more important definition. The circle C of radius delta with the center at the point z0 can be represented by can be represented by mod z minus z0 equal to delta. So what is the node 2? Node 2 is the distance between 2 points z and z0 is denoted by mod z minus z0. Next node is the circle C of radius delta with the center at the point z0 can be represented by z minus z0 equal to delta. Node 4, mod z minus z0 less than delta, mod z minus z0 less than delta represents mod z minus z0 less than delta represents the interior of the circle the interior of the circle the interior of the circle excluding its circumference. Okay, excluding its circumference. Mod z minus z0 less than delta represents the interior of the circle excluding its circumference. Okay, that means we can consider one circle with radius delta and then center z0 here, and then z minus z0 less than delta means all the points which include inside that circle excluding its circumference. Note 5, mod z minus z0 less than or equal to delta represents mod z minus z0 less than delta represents the interior of the circle including its circumference. I think it is F now. Okay, fine. Next note, the circle of radius 1, with the center at the origin, the circle of radius 1 with the center at the origin, can be represented by mod z equal to 1. It is also known as unit circle. Important definition. Neighborhood. Simply write that NBD, neighborhood of a point. Neighborhood of a point Z0 is x-axis, is y-axis, and then you draw the circle. The delta center is Z0 here. Neighborhood of a point Z0, NBD, neighborhood of a point Z0, we mean sufficiently small circular, sufficiently small circular region, sufficiently small circular region, excluding the points on the boundary, excluding the points on the boundary, with the center at Z0. That is mod Z minus Z0 less than delta. Here, what is meant by that neighborhood of the point? Neighborhood of the point. Now listen, the distance and the center is not depend upon the size, it is depend upon the particle. Listen, for example, okay, if we consider it is not the circle, it is a rectangle. All the persons inside the class are the neighborhood. Come after 10, 11:30. Listen, see here, if you get one circle here, so inside which is covered by me, that means all the points inside the class are known as that neighborhood. In case if they are that outside the class, they are not that neighborhood. One more simple example, if we take earth, okay, case if we take earth and then sun is here. See, for the distance between the sun and earth, consider with that moon is there in middle, that is a neighborhood. So distance is not the matter, and then neighborhood is the based on the particle. That is depend upon your definition only. You may take the delta, radius delta as that you can take 1 millimeter, 1 nanomillimeter, or you can take the delta as that 1000 kilometer or 1 lakh kilometer also. We don't know this. If you are taken that this is that 1 millimeter or 1 centimeter, within the 1 centimeter how many particles are there? That is a neighborhood. In case if you are taking it is that 1 lakh kilometer is there. Within that 1 lakh kilometer, what are the particles are there? Then it is known as that neighborhood. So what is meant by that neighborhood? You can put any circle and then within the circle what are the particles are there, that is known as neighborhood of the point. Okay, listen. So what is a point here? It is a point. You can take here, that here. That is depend upon your definition. You can take it is that very small, or you can take it is that very large. Okay, fine. Next one is fine. Derivative of a function. Write down derivative of a function. Now listen. See, derivative of a function is that if y equal to f of x is there. If y equal to f of x is there, it is a simple derivative. We can write that dy by dx or f dash of x simply we can write. But here, in case if you are derivating z, it is not the simple derivative because z contains x and y. Two functions are there. Then simply you are not able to write the dz. Okay, fine. So derivative of a function is for a real function. Write down. For a real function, of a single real variable, of a single real variable, of a single real variable, y equal to f of x, y equal to f of x, the derivative of y with respect to x, for a real function of a single real variable y equal to f of x, the derivative of y with respect to x is dy by dx equal to limit delta x tends to 0 f of x plus delta x minus f of x divided by delta x. Okay, let at the same time, in case if you want to define w equal to f of z is, let w equal to f of z be a single valued function. Single valued function. W equal to f of z is a single valued function of z. Then the derivative of w is defined as w dash equal to f dash of z for limit delta z tends to 0 f of z plus delta z minus f of z divided by delta z. Okay, listen. So here delta z tends to 0 means either delta x tends to 0 or delta y tends to 0. So here we have to write that z is x plus iy and then delta z is delta x plus delta iy. So which both of them tends to 0, that means it can be written as case P of x comma y is here, and then you can draw this diagram. The point Q is here, x plus delta x comma y plus delta y, where it tends to 0 in multiple way. First delta x tends to 0, or first delta y tends to 0, or both of them are tends to 0. Let P of z and Q of z plus delta z, P of z and Q of z plus delta z be two neighboring points, two neighboring points, two neighboring points. The point Q may be approached, the point Q may approach P along any straight line, along any straight line, along any straight line, or curved path, or curved path. See, what is the curved path here? It may be come like that also. This is also the curved path. You can write in the different in the given region. So for this, so you should know that what is the limit of the function. So you should know that what are the things you know need to be studied from +2 level is, in the derivative you need to study what is the limit of the function, what is the continuity of the function. These two topic is very important. Limit of the function, continuity of the function. These two topics I am not able to revise now because already you have studied in +2 level. Yeah, this two is important. Limit of your function and the continuity of your function. When that function is said to be discontinuous, when that function is said to be continuity, when that function is said to be discontinuity, these points you have to be very clear. Even you can download the book from +1 or +2 level, please go through it. It will be very useful for this. And then you can read about that complex function which is available in +1 +2 level. Okay na? Fine. Now these are the introduction point of that the complex and the complex variable. Now we enter into that first topic, analytic function. Write the heading analytic function. See, last two classes we have discussed only the basic introduction part. Now only we are enter into the your syllabus analytic function. Definition. Definition. Analytic function. Need to see this one also. Well, definition. Analytic function. Write in the bracket. The analytic function, also known as that regular function, may come in the MCQ. Regular function or holomorphic function. Analytic function, regular function or holomorphic function. Write the definition for this. A function defined at a point z0 is said to be analytic. A function defined at a point z0 is said to be analytic at a point z0 if it has derivative at z0 and at every point in the neighborhood of z0. In the neighborhood of z0. I repeat that a function defined at a point z0 is said to be analytic at a point z0 if it has derivative at z0 and at every point in the neighborhood of z0. If it is analytic, at every point, in a region or capital R, then it is said to be analytic. In the region R. Then it is said to be analytic in the region R. The necessary condition is very important. The necessary condition, because all the problems will be doing based on this condition only. The necessary condition for f of z to be analytic. to be analytic. This conditions is known as that Cauchy-Riemann equations. This even you can put the two important sign points. The necessary condition for f of z to be analytic are Cauchy-Riemann equations. The necessary condition for a complex number not a complex number, here we are not considering number, no? Complex function. The necessary condition for a complex function f of z equal to u of x comma y plus iv of x comma y to be analytic or dou u by dou x equal to dou v by dou y and dou v by dou x equal to minus dou u by dou y, or simply we can write that u suffix x equal to vy and v suffix x equal to minus uy. That is, for that complex function w equal to is there, w equal to u and v, z is there, z is a function of x comma y. So easily you can remember that. Okay, for that analytic function u dou e by dou x, dou v by dou y, straight. Okay, straight line is positive. In case cross is there, dou v by dou x equal to minus dou e by dou y. Here for the opposite minus, for the positive it is plus. Okay, it is possible to remember na, dou e by dou x equal to dou v by dou y and then dou v by dou x equal to minus dou u by dou y. So how can you check it is that analytic or not? How can you check it is the analytic or not? Okay, fine. We can do the problem in the next class.